Today we are going to cover sections 5.1 and 5.2, rational functions and graphs. Take the time to copy your title and your essential question. How do you sketch the graph of a rational function? Paste your cutout, write example number 1, and we'll start once you are ready. Go and pause it. So rational functions. A rational function can be written in the following form, where we have a function equals two functions, your numerator function and your denominator function. Remember, the word rational comes from the word ratio, which is a fraction. And your numerator and denominator will be polynomials. And d of x, your denominator function, is not a zero polynomial because if it's a zero, it'll be undefined, correct? So now we are going to graph the function f of x equals 1 over x. I'm going to make my graph at the center. So therefore, I'm going to make it 5 by 5, 2, 4, 5, 2, 4, 5. And in order to graph it, I am going to make a table of values. So let's make a table of values on the left, where I'm just going to plug in values for x, and that'll give me back values for y. Plug in values for x, which will return values for y. And I'm going to start graphing it. So what value should I plug in first? I should plug in a 0. Remember, and you can do this with any graph. If you're not too sure about the shape, we can just go back to plugging in points, connecting the points, and that'll give me the graph. So plugging in 0, 1 over 0 will be undefined. So that does not give us any points here. I'll plug in a 1 will give me 1 over 1, which is 1. So plugging in 1 gives me 1. I'm going to plug in a 2. 1 over 2 will give me 1 half. So plugging in 2 gives me 1 half. I'll plug in a 3. 1 over 3 will give me 1/3. So divide this into 3 sections, take 1. Plug in a 4 will give me 1/4. Plug in a 5 will give me 1/5. Plug in a 6 will give me 1/6. Plug in a 7, 1/7. Plug in a 20, 1/20th. Plug in a 100 will be 1 over 100. So it's never going to reach 0. It's never going to reach that x-intercept. Now, if I want to be able to find out what happens somewhere over here, because it seems like it's going to be around here, I'm going to plug in a 1 half. If I plug in a 1 half, that'll be 1 over 1 half, which will be, so if I divide 1 divided by 1 half will give me 2, correct? So 1 divided by 1 half is 1. Change the division to multiplication and take the reciprocal, so it gives me 2. So this will give me 2. 1 half gives me 2. Plug in a 1/3 will give me, correct, 3. So plug in a 1/3 gives me 3. Plug in a 1/4 gives me 4. Plug in a 1/5 gives me 5th. Plug in a 1 over 100 gives me 100. Plug in a 1 over 1,000, which is very close to the y-axis, to 0, will give me 1,000. So therefore, your graph comes down from here, and it's never going to, at 0, it's undefined. So whenever it's undefined, in this case, we are going to have something that we called, do you remember the name of this dash? That is called an asymptote. And we're also going to have one on the x-axis, since on this side it's going to get closer and closer to 0 but never touching it. And on the left hand side, let's see what happens on the left hand side. So on this side, we know that it's going to get closer and closer to your asymptote, but it's never going to cross it, never going to touch it. And the same thing here. Now, if I want to find out what happens on the left, I'm going to plug in a -1. So if I plug in a -1, gives me 1 over -1, which is -1. Plug in a -2, will be 1 over -2, which is -1/2. Plug in a -3, and you get the idea, right? 1 over -3 will give me a -1/3. Plug in a -4 will be -1/4. Plug in a -5, -1/5, and so on. So therefore, that happens here. And now if I plug in a -1/2, that same thing is going to happen as it happened here, correct? It'll be 1 over -1/2 will give me -2. They'll give me -3, -4. So therefore, on this side, there'll be an asymptote as well. So your graph is going to get closer and closer to your asymptote, but it's never going to cross it. And on this side, it's going to get closer and closer and closer to your asymptote, but it's never going to cross it. So we do need to be able to write down your equations for your horizontal. We have a horizontal asymptote. Which is y equal to 0. We also have a vertical asymptote. It's a vertical line, so it'll be x equal to 0. We also need to be able to write our domain and range. So your domain and your range. So your domain, you want to be able to think about two different ways. You want to be able to think of it as algebraically for your domain. What values can I plug in for x? Can I plug in a negative number? Yes. Can I plug in a 0? No. Can I plug in any positive values? Yes. So all the values except for 0. And you can see that on the graph. Your domain is all the values except for 0. So we can say all real numbers except when x equal to 0, or we're going to write down as an interval notation from -infinity all the way up to 0. Remember that it doesn't include 0, so we're going to leave it as open. And then we're going to start again from 0 all the way to +infinity. And we're going to place a union. Your range will be the same, right? From -infinity to 0, not including 0, and from 0 all the way to +infinity. Those are the values that we get back from the function. And we never get back at 0 because at 0, it never crosses the x-axis. And let me place a union as well. So this is just as a quick overview of what you guys covered before. Let's go through some rules. So take the time to copy or paste your cutout, and we'll start once you are ready. Go ahead and pause it. Asymptotes of a rational function. Let f be the rational function given by your numerator polynomial over your denominator polynomial, where n of x and d of x have no common factor. So therefore it has been simplified. I will go over a few cases where we need to simplify. The graph of f has vertical asymptotes at the zeros of d of x. So therefore, in order to be able to find your vertical asymptotes, we need to be able to find the zeros of d of x just like we did last time. On the last chapter when we found the zeros of polynomials. The graph of f has horizontal asymptotes determined by comparing the degrees of the numerator and denominator. And we have three cases. If your numerator degree is smaller than your denominator, so therefore the degree of your numerator is smaller than your denominator, then f has the line y equal to 0 as a horizontal asymptote. If the degree of the polynomials are the same, then f has the line y equals a sub n and B sub n as the horizontal asymptote, where A sub n is the leading coefficient of your numerator and B of m is your leading coefficient of your denominator. And the last case that we have is that if your numerator has a bigger degree than your denominator, then it has no horizontal asymptotes. So let's go through the first case. F of x equals 1 over x to the third. We are going to graph it, so let's go and make a graph. We're going to make it 5 by 5. 2, 4, 5. And now the first thing that we're going to find is your vertical asymptotes. So your vertical asymptote is going to be found by finding the zero of your denominator. So therefore, we're going to place your denominator equal to 0, so we can find the 0. So x plus 3 equal to 0. So therefore, x equals negative 3. That'll be your vertical asymptote. So first thing we're going to do, we are going to place a vertical asymptote all the way through. Now we need to be able to find our horizontal asymptote. And now to be able to find the horizontal asymptote, we need to be able to determine whether it's case 1, case 2, or case 3. So in this case, what is the degree of the polynomial above? It doesn't have an x, so therefore the degree is 0. And this has a degree of 1. Correct? So therefore, the degree of the numerator is smaller than the degree of the denominator. So this is case 1. So some of the examples that you guys will see, let's write down the first example. So if you have f of x equals 1 over x plus 3, or we can have f of x equals, if you have x over x squared minus 9, your numerator has a smaller degree than your denominator. Then, or if you have f of x is equal to 3 over x squared minus 7x plus 10, then your numerator has a smaller degree than your denominator. So all three of them will be case 1. So therefore, if this is case 1, therefore, and actually I should write it case 1. So therefore will be y equal to 0. That means that your asymptote, your horizontal asymptote will be on the x-axis. And now we're just going to be selecting additional points. We know that our graph should be in any of those 4 corners. So I'm just going to plug in 1, 2 values. I want to make a table of values. I want to plug in values for x, and it will give me back values for y. And now I need to be able to plug in values to the right and to the left. I'm going to plug in values to the right, so I'm going to plug in a negative 2. And that gives me 1 over negative 2 plus 3. which would be 1 over 1, which will give me 1. So if I plug in a negative 2, it's going to give me 1. So therefore, I know that this part of the graph will be on this side. And we know the shape because we got the parent graph. And it can act as your x-axis. So remember that it has to get closer and closer to your asymptotes. It cannot cross your asymptote. It has to get closer and closer. And now I'm going to plug in a number to the left. So therefore I'm plugging a negative 4. So if I plug in a negative 4, I end up with 1 over negative 4 plus 3. This gives me negative 1, so therefore it will be negative 1. So therefore the other part of the graph will be on this side. And let me extend my asymptote all the way through. So therefore your graph is going to get closer and closer to your asymptote, but it's never going to cross it. Every time it gets closer and closer, and remember that if you do cross it, I'm going to take a point out from you. So it's essential that you're not crossing your asymptote, it's getting closer and closer every single time. So the last thing that I need to do is my domain and range. So let's go and find your domain and your range. So my domain, what is my domain? All real numbers except for negative 3, since I cannot plug in a negative 3. So it'll be from negative infinity all the way to negative 3. Does not include the negative 3, and then we continue from negative 3 all the way to positive infinity. And it's a union. Your range are your y values. What values do we get back from negative infinity all the way to 0? Union. And from 0 all the way to positive infinity. So remember that you need to be able to give me your vertical asymptote, your horizontal asymptote, your domain and range. Now the book will also find your x and y intercepts, but we are not going to do that for this class. It's a simple process, but it just takes a little more time and gets a little tedious after a while. Example number 3. Go and copy it down, and we'll start once you're ready. Go and pause it. So I'm going to make a 5 by 5 graph. And the first thing I need to do, I need to be able to find my vertical asymptote. So let's go and find your vertical asymptote. And how do we find your vertical asymptote? Right. And now one of the things I'm going to do first, every time I have a polynomial, I'm not going to factor it. F of x equals, because I'm going to need that anyways. So first thing we should do first thing is to factor each your numerator and your denominator. In this case, nothing to factor out, so I can just use my double parentheses. Factors of x squared will give me x and x. Factors of 6 will be 3 and 2. One positive, one negative, so it'll be a positive and that should be a negative. Correct? So now we can actually find your vertical asymptotes. Your vertical asymptote is x equals negative 3 and x equal to positive 2. So in this case, we're going to have two vertical asymptotes, one at positive 2 and one at negative 3. Now we need to be able to find our horizontal asymptote. To find your horizontal asymptote, you need to be able to decide which case is it. Is it case 1, case 2, or case 3? So let's see. the degree of this polynomial is 1. The degree of your denominator is 2. So therefore, we're still in case 1. Your numerator has a smaller degree than your denominator. So this is case 1. So therefore, if it's case 1, your horizontal asymptote will be y equal to 0. Now, the book does it slightly different to find your horizontal asymptotes, but we are going to go through that process once we reach chapter 13. Once we start talking about limits. And we'll come back to the notes and your cutout to be able to talk a little about the connection between chapter 13 and this section as well. But for now, I need to be able to determine what happens in this section, what happens here, and what happens here. So I need to plug in 1, 2, 3, 4. So I'm plugging a 1 and a 3. I'm plugging a 1 to see what happens here, a 3 to see what happens here. I'm plugging a negative 2 and a negative 4. So let's just make a quick table of values. And I'm going to either use scratch paper or just use my calculator. Either one is fine. Plug in X and Y. I want to just use scratch paper. This is small numbers. So let's plug in let's start over here, negative 4. If I plug in a negative 4 over negative 4 squared is 16 minus 4 minus 6. So it gives me negative 4 over 6. So it gives me negative 2/3. Correct? Now, so negative 4 gives me negative 2 and 3, 2/3. It's right here. We'll check. Negative 4 gives me 16 minus 4 minus 6. So now I'm going to plug in so therefore in this section, the graph will be over here in my class, and then I'll follow my asymptote. I'm going to plug in a negative 2. I have a negative 2 over negative 2 squared is 4 minus 2 minus 6. So it gives me negative 2 over, that gives me negative 8, negative 4. So it'll be 1/2, positive 1/2. And now this section will be over here. Now I want to be able to find out what happens at 1. So this will give me 1/2. I'm going to plug in a 1. If I plug in a 1, gives me, I'm going to plug it in over here. 1 squared is 1 plus 1 minus 6. So it gives me 1 over negative 4, which is negative 1/4. So 1, plug it in, gives me negative 1/4. So notice that this part on this section is coming down over here. But on this section is coming down over here. And therefore it's going to cross somewhere in that section. So some of you will say, hold on, DS, first you said that this was your horizontal asymptote, but then you tell me that it's crossing. So yeah, there'll be sometimes that in this case, whenever you have 3 components, it might cross your x-axis. Your asymptotes will only apply on the left and on the right. So that gives me negative 1/4. And now I'll plug in a 3. So that gives me 3 over 9 plus 3 minus 6. So with 3 over 6, which is 1/2. So therefore, that will be on this section of the graph. And now we just need to be able to find your domain and your range. So to be able to find your domain, so your domain, it's all your numbers except for -3 and +2. So we're gonna have three sections for your domain, from -infinity all the way to -3, not including -3, union from -3 all the way to +2, not including +2, and from 2 all the way to +infinity. And your range. Your range, in this case, will be all real numbers, because even at 0, we do get a value. Now, if you want to be able to find out where it crosses your x-axis, we can find your x-intercepts, but we are not going to do it for this class. Your book does go through a process, but for now, we're going to minimize the work by just knowing that it crosses somewhere in there. Before I continue, let's go and use decimals to graph the function, and let's go back to example number 1. Now let's go and graph the first one. So I'm going to graph it, and we are going to use decimals because it's going to allow us to do things a little faster than the graphing calculator and to be able to make some connections. So that is a graph of 1 over x. And notice that on the right hand side it's getting closer and closer to 0, but it's never going to reach it. Even if I zoom out, it's going to get closer and closer to 0, the y value, but it's never going to reach it. If I zoom out, closer and closer, and so on. You get the point, right? So getting closer and closer to 0, but never crossing. For the second, whenever you think about moving a +3, you can just think about shifting the graph to the left 3, right? So if I do an A here like we've done before, so we're still shifting your graph to the right, and to the left. So we still can talk about shifting left and right depending on the value they're plugging in here. And even if I place a value here, what happens if I place a +1? Moves it up. +2 moves it up, +3, +4, +5. So we can still talk about that. If I plug in a -1, -2, -3, we'll shift it down. So we can still talk about your shifting. So on the second example, because we had a +3, that means that your graph got shifted to the left 3 spaces. And that was example number 2. Now if we graph example number 3, we have just the one that we just did, x squared plus x minus 6 minus 6. And notice that it does cross, and in this case it crosses at 0, 0. And we can actually find your x and y intercept by it does cross the point, and you can see it doesn't show you vertical asymptotes, and that's why we do a dash, or your horizontal asymptotes in here. So this was just a very easy way to be able to graph functions. So let's continue with example number 4. So now let's continue with example number 4. Go ahead and take the time to write it down, pause it, and we'll continue once you're ready. So once again, I'm going to make a 5x5 graph. Now, one of the things that we want to make sure that we remember is that every time we have a rational function, we want to make sure that we factor this out. So therefore, I notice that my denominator can easily be factored out. So we have x plus 3 over, and That's the difference of two squares, so x and x, 1 negative 3, 1 positive 3. And one of the things I will notice is that we can simplify this fraction, so that cancels out. So therefore, the function that we are going to graph is the simplified version of the function, which is f of x equals 1 over x minus 3. And now we can graph it. So first I'm going to find my vertical asymptotes. So therefore my vertical asymptotes are found by finding the zeros of your denominator. So therefore x equals negative 3, so therefore x equals 3 will be my vertical. X minus 3, so therefore x equals to positive 3. That'll be my vertical asymptote at 3. Then I need to be able to find my horizontal asymptotes. So in this case, we need to be able to see, okay, which case is it? Case 1, case 2, or case 3? So let's see, the degree of either this polynomial or this polynomial. In this case, the degree here is 1, and the degree is 2. So therefore, the degree of your numerator is smaller than the degree of your denominator. So therefore, it will be case 1. And even if we look at this function, the degree of the polynomial of 1 is 0. The degree of this polynomial is 1. So therefore, it is case 1. And since it's case 1, we know that it will be y equal to 0. So therefore, my horizontal asymptote will be at the x-axis. And now we're just going to make a quick table of values. I'm going to plug in values to the right, values to the left, go ahead, pause it, and see what your graph looks like. You got it? So in this case, make a quick table of values. Plug in values for x, will give me back values for y. I'm going to plug in values to the left, so I'm going to plug in a 2, and then I'm going to plug in values to the right, so I'm going to plug in a 4. If I plug in a 2 in here, this will be 1. It'll be 2 minus 1, it'll be negative 1. So it will be 1 over 2 minus 3, which is negative 1. So therefore, negative 1. So 2, negative 1. So therefore, this part of the graph will look something like this. It'll go through. Remember that it's going to get closer and closer to your asymptotes, but it's never going to cross it. And now on this side, I'm going to plug in a 4. So it'll be 4 minus 1 will be, 4 minus 3 will be 1. So it'll be 1 over 1, which is 1. And therefore, my graph will look something like this. It's not crossing through it. Seems like it is, but it's not. And now, we do have something at, in this case, because the x plus 3 cancel, when x equal to negative 3, is going to be an open circle. And if we go into decimals, now if I graph my original function, let me get rid of this. We had x plus 3, x squared minus 9, Notice that's the function that we have. And if we look at the graph, we get points throughout, but once you reach -3, once we get to -3, you'll notice that there's a -3 is over here. Notice that a -3 will be undefined. So we have a hole in the graph. So we need to make sure that we also place a hole in the graph, and that's going to happen when we are simplifying your expression. So this an open circle, which means there's going to be a hole in the graph. At -3, it'll be undefined. Because even though we simplify, we still are graphing this function. But in order to be able to graph this function, we need to be able to simplify it. And that's why. Now notice that what is the difference between this function and if I just actually do f of x equals 1 over x minus 3. Notice that they're the same function. The only difference that if I graph this one, the value at -3 does exist. Where once I graph the original function, it's the same function. The only difference is that little gap right there. So we have domain and range. Our domain will be from -infinity all the way to -3. Open. Union from -3 all the way to 3. Union. And from 3 all the way to past infinity. And notice that I place parentheses on each one because it doesn't include the -3 or the 3. Or we can say all real numbers except for -3 and 3. And your range. So for your range will be all real numbers except for 0, or we can say from -infinity all the way to 0, and from 0 to positive. Those are all the y values that we get back. Let's continue to example number 5. Go ahead and take the time to copy it down, and then we'll continue once we're ready. So first, let's make a 5 by 5 graph. I need to be able to decide if I can simplify. So if we can simplify, we should simplify first. I notice that I cannot simplify in this case, correct? So therefore, I'm going to find my vertical asymptote first. And I notice that my vertical asymptote is when the denominator becomes 0, which will be -1. So x equal to -1. That will make my denominator 0, which makes it into an undefined, which creates an asymptote. My horizontal asymptote. So I need to be able to decide, is it case 1, case 2, or case 3? So I'm going to be looking at which case is it. Let's see. The degree for the numerator is 1. The degree for the denominator is 1. So therefore they equal to each other. So therefore it's going to be case number 2. On case number 2, we are going to begin the coefficient for your numerator, your leading coefficient, and your leading coefficient for your denominator. So therefore it will be y equals, and that'll be 2 over 1. So therefore it will be y equal to 2. So whenever your degree of the polynomial is the same, then we're going to get the leading coefficients for your numerator denominator. So therefore, y equal to 2 will be your horizontal asymptote. And now we are going to make a table. And I have a little more space here, so let me make a table on the right hand side. And now I'm plugging values for x, my values for y. So plug in the different values, see what you get for your graph, and then we can compare our answers. Go and pause it. So in this case, I'm going to plug in a -2 and a 0. If I plug in a -2, I end up with 2 times -2 plus 3. So it's -4 plus 3. So it'll be -1 over -1, which is 1. So plug in a -2, I end up with 1. So therefore, that part of the graph will be on this side. And now I'm going to plug in a 0. Plug in a 0 gives me 3. 0, and that gives me 3. Close it, but not touch it. Perfect. And then the last thing I need to find is my domain and range. So find your domain and range, and we can compare afterwards. So what is your domain? All real numbers except for -1, or from -1 to -infinity to -1, union from -1 all the way to positive infinity. And your range, all real numbers except for 2, or from -infinity to 2, and from 2 to positive infinity. Example number 3. Go ahead and take the time to copy it down, and then we can compare our answers, or we'll start graphing it together. Let's make a 5 by 5 graph. So the first thing that we should do, we should factor out to see if we can simplify it. So if I notice I can factor an x from here. So let me just go through the process. Every single time you want to be able to factor it out to see if we can simplify, to see if we have any holes on our graph. X minus 1, and we have x plus 1. So in this case, nothing to cancel. So we are going to just graph the given function. So I'm going to find my vertical asymptotes. My vertical asymptote is what? So what is your vertical asymptote? This is when x is equal to -1. That will make your denominator 0. So that will create an undefined, which will create your asymptote. Now your horizontal asymptote. To find your horizontal asymptote, I need to be able to determine whether it's case 1, case 2, or case 3. So let's see. In this case, the degree of the numerator is 2. The degree of your denominator is 1. So therefore, the degree is greater on the numerator. So no, is not equal. So it'll be the third one. Therefore, it has no horizontal asymptote. None. But it does have a slanted asymptote, and we're going to find it by making it by using long division or syntactic division. So you need to be able to simplify this. Do you prefer to use long division or syntactic division? Let's use long division just to practice a bit more. So therefore I want to divide. I might place my division, so it'll be x squared minus x, and missing a term of plus 0. Outside will be x plus 1. Or if you want, you can do synthetic division whenever you have a x and a number. So go through the process, see what you get for your long division, and then we can compare our answers. So therefore, x goes into x squared, I need an x times x is x squared, x times 1x is positive x. I'm going to go and multiply by -1, or just change the signs. That cancels, so I end up with -2x. Bring down the next term, and I end up with -2. -2 times x is -2x. -2 times 1 is a -2. Positive, positive, cancels, so I end up with positive. This is going to be your asymptote, your slanted asymptote. Will be y equal to x minus 2. So therefore, if you don't have a horizontal asymptote, we go through the long division to find your slanted asymptote. So therefore, I'm going to graph the asymptote. -2 is my y-intercept. My slope is positive, 1 over 1. And now I'm going to decide whether on the left hand side my graph will be here or here. On the right hand side, whether it's on this section or on the bottom section. And the only way to find out is to be able to make a table of values. So I'm going to plug in the -2 to be able to determine whether it's here or here. And then I'm going to plug in a 1 to determine whether it's here or here. So I'm just going to make a quick table of values, and I'll make it here. I'm going to plug in values for x, gives me back values for y. I'm going to plug in a -2, and then I'm going to plug in a 1. And let me just do it on a separate piece of paper. I have to plug in a -2, so it'll be positive 4, minus -2 becomes a positive 2. This is -2 plus 1, so it'll be 6 divided by -1, which is -6. So therefore, that gives me a -6, 2, 2, 4, 6. That means that graph will be on this side. So let me just make my asymptotes a little longer. And it's going to come through here. It's going to pick up that point. And it's going to come back down. And now we can most likely assume that it's here, but we can't take it for granted. So I'm just going to plug in a 1. So it'll be 1 squared is 1 minus 1, and that gives me 0. Gives me 1 plus 1, which is 2. So it'll be 0 over 2, which is 0. So therefore, plug in a 1, plug in a 1. Actually, I should plug in a 0, right? Actually, plug in a 0. That'll be a more proper way of doing it. Let me go back and fix it. So why am I plugging in a 1? Really, I should plug in a 0 so I know where it's located. Plug in a 0 gives me 0, 0, gives me 0. So also gives me 0 here. And it gave me 0 here, so I know that's going to come down. I'm going to go pick up that point. It's going to pick up the other point and go this way. And we can always double check your answers on decimals. So if I just go through and confirm that's correct, we have x squared minus x over x plus 1. You'll notice that we have, and those are the points that we found and we found that to be, if we want to be able to do this through decimals, we can plug in a -2. That gives me -2 comma -6. That is the other point that we found. Domain and range. So let's just find our domain and our range. Our domain will be all real numbers except for -1. So from negative infinity all the way to -1, and from -1 all the way to positive infinity, union. And your range. Now, ideally, I should be able to find this highest point, and let's see, can I do it through decimals? No, so in this case, we are not going to worry about your range. Or this, it does give you the, so we can, but for this function, I will not be asking you for your range. Let's ignore that for now. Because otherwise we need to be able to find the highest point in this section and the lowest point, and you'll find that in calculus, not yet. Example number 7. Go and copy it down, pause it, and let's make a 5x5 graph. So pause it if you need more time. So first, what should I do first? See if we can simplify. Can I factor the denominator? No. So therefore, I'm going to find my vertical asymptotes first. Your vertical asymptote is what value will make this a 0. Correct? We're finding the zeros of the denominator, so therefore let's just do it manually. X squared plus 1 equal to 0. Move the 1 to the right, becomes a -1. Take the square root on both sides. And the square root of -1 is I, plus or minus. So therefore, there are none. It doesn't have any vertical asymptotes. There are no values for x that will make the denominator 0. Let's find our horizontal asymptotes. So therefore, which case is it? Is it case 1, case 2, or case 3? You decide. Correct. It's case. Did you guess it right? Yeah, case 1. Degree is 0 for the polynomial, degree is 2. So therefore, your horizontal asymptote will be y equal to 0. So therefore, in order to graph it, we just need to be able to make a table, plugging values for x, that'll give me back values for y. When I plug in a 0, this becomes 0, so it gives me 1. When I plug in a 1, this is 1 squared, so plug in a 0, gives you a 1. Plug in a 1, gives you 1/2. Plug in a 2, that'll be 4, 1/5. And therefore, plug in a 3, that'll be 3 squared is 9, plus 1 is 10, so 1/10. And so on. So it's going to look something like this on this side. On the left hand side, if you plug in a -1, it's going to be square. So the -1 squared is 1, gives you 1, plus 1 is 2, so it'll be 1/2. Plug in a -2, will give you 1/5. So therefore, this graph looks something like this. So therefore, your domain and range. What is your domain? Your domain is all real numbers from negative infinity to positive infinity. There are no restrictions on what values I can plug in for x, especially because of the square will never be, this denominator will never be 0. Your range will be from 0 all the way to 1. 9 including 0 or including 1. That's it. 0 is never part of the answer, and 1 it is, since we got 1 there. And if we graph it on Desmos, that's what it looks like. So we are correct. Now, let's just briefly write an example for number 8, 9, and A, B, and C. Go and pause it, and then the only thing that we're going to do, we're just going to do a quick sketch. Your book will actually, we're just going to do 4x4 graphs. So 2, 4, 2, 4. And we're not going to graph them by hand. Your book does do a bit more. They always find your x and y intercepts, which is a quick process. To find the x-intercept, you let y equal to 0. To find the y-intercept, you let x equal to 0. But it just takes a little bit longer, and the work gets to be a little too tedious. But you can if you want. And for this one, we're just going to do a very quick sketch. We're not going to graph them by hand. And your book does do it by hand, but not for our purposes. So now if we just graph the first one, will be, now remember that sometimes we think that plus 1 should be shifting it up or down. In this case, that's x squared plus 1. And problem number 7 was a plus 1. The two different graphs. If you wanted to think about shifting it up, you'll be the plus 1 here. Now in the denominator. Right? Or even if you think about shifting it left or right, the plus 1 will be inside, not outside the square root of the square. So that is the graph of 1 over x squared. You're not expected to know this for the test. We're just going to cover it right now. So let's just go ahead and copy down the graph, very quick graph on your paper. The graph comes down from here. Basically, it's on one side and on the other side. Just because it's square, there are no negative parts. Where you have a vertical asymptote at 0 and horizontal asymptote at 0 as well. Then for the second one, we have -2. And notice in this case, if I zoom out, your horizontal asymptote is at 1, 1 over 1. So the same rule applies. The degrees are the same. If I do y equal to 1, that's your horizontal asymptote. But then it does cross it. And your book has some examples on some of the rules, but we're not going to cover that in the class. So let's just do a quick sketch. Your vertical asymptote is at 5, at -5. It seems like there might be, yeah. So just make a quick sketch. Horizontal asymptote, I'm going to copy it down. Vertical asymptote will be at -5. And then it crosses at -1. And at 2. And your book goes over a few more properties for rational expression. So therefore it comes down over here, goes up, and follows yours. Then on this side, it goes on. but we are not going to cover that in the class. And for the last one, we are just going to graph it. So these are more graphs that you guys will see once you take higher level mathematics. This is to the third power. Remember what graphs to the third power looks like? 1, 2, 3. And that is the graph. And notice that in this case, it has a slanted horizontal, slanted asymptote here. And you can think about that process. And that's because the degree of the polynomial on the numerator is bigger than the degree on the denominator. No horizontal asymptote, but it's a slanted asymptote. We can do the long division to find the asymptote itself. But for now, we're just going to do a quick sketch. And I'm just going to plot those points. One, two, three, but still has an asymptote, still a rational expression. So this will conclude the lesson for today. Have a great day, and I'll see you guys next time.